Hey, if you're a junior developer looking to get your feet wet with NoSQL, you are in exactly the right place. In this quick guide, we're going to break down the MongoDB document model from the ground up, giving you everything you need to hit the ground running.
Okay, so here's our game plan. We'll start with the big picture, what MongoDB actually is. Then we'll zoom right into its core building blocks, databases, collections, and the documents themselves. And to wrap it all up, we'll look at a really powerful feature called views that can totally level up how you work with your data.
So, first things first, what exactly is MongoDB, And why has it become so incredibly popular for building all sorts of modern applications?
Well, the most crucial thing to understand is this. Instead of the rigid rows and columns you might be used to from SQL databases, MongoDB uses a flexible document model. If you've ever worked with JSON or JavaScript objects, this is going to feel incredibly natural. The whole idea is to make your development process faster and just way more intuitive.
Now, what's really cool is how all these core features work together. You got that flexible document model, which is great for agile development. But you also get full ACID transactions, so your data stays consistent. Then there's high availability through replication, which means your app won't go down. And finally, horizontal scaling to handle just massive amounts of data. It's really built to support everything from a weekend prototype to a huge, mission-critical application.
All right, let's move up to the highest level of organization in our new data universe. This is really the starting point for everything we're going to build.
A database is pretty simple. It's just the main container. I absolutely love this filing cabinet analogy. It's the big cabinet where you'll store all the related info for a single application. So for example, you might have one database for your e-commerce store and a completely separate one for your company blog.
Okay, so we've got our filing cabinet. Obviously, we need a way to organize the files inside, right? We can't just throw everything in together. And that's exactly where collections come into play.
A collection holds a group of related documents, just like a single drawer in that cabinet holds a set of related files. So you might have a users collection, a products collection, and an orders collection. It's pretty similar to the idea of a table in a traditional relational database.
And this right here, this illustrates one of MongoDB's biggest strengths. Unlike a rigid SQL table, documents inside the same collection don't have to share the exact same structure. One user document might have a middle_name field, while another one doesn't. This flexibility means your data model can evolve easily as your app grows, without you having to do those painful database migrations. It's a game changer.
Now we get to the absolute heart of MongoDB, the core unit of data itself. We're talking about the individual record.
So each document is a single record, like one file in our drawer. It's stored in a format called BSON, which stands for Binary JSON. Just think of it as a superpowered version of JSON. Because it's binary, it's more compact and way faster for computers to parse. And it also supports extra data types that you don't get in standard JSON.
The basic structure is going to look incredibly familiar to any developer. It's just a simple set of field and value pairs, exactly like a JavaScript object or a Python dictionary. This is what makes working with MongoDB feel so seamless right inside your code.
But here's where the real power is. A single document can represent really complex hierarchical data. I mean, look at this. You can have embedded documents, like the name field here. You've got arrays, like contribs, to hold a list of values. And you have all these special BSON types, like dates, object IDs, and even 64-bit integers with number long. This lets you model your data in a way that perfectly mirrors your application's objects, all in one self-contained unit.
Now, you probably noticed that special _ID field in that last example. Let's talk about that for a second, because it is absolutely essential to understand. This is the unique identifier for every single document in a collection. So here's the deal. Every single document in a collection must have a unique _ID value. It always comes first in the document. And if you don't provide one yourself when you insert a document, don't worry. MongoDB will automatically generate one for you. This _ID is also automatically indexed, which ensures data integrity and makes looking up a specific document incredibly fast.
Okay, so we've got our data structured, and every document is uniquely identified. That's our single source of truth. But what happens when you need to present that data in a different way, maybe for a report or an API endpoint, but without actually duplicating everything?
This is exactly what views are for. You can think of a view as a saved read-only query that you can interact with just like it was a regular collection. They're perfect for shaping your data differently.
maybe to hide sensitive fields like personal information, or to pre-calculate some complex metrics for a dashboard.
And MongoDB actually offers two types. Standard views are calculated on the fly every single time you query them, so they don't take up any extra storage. On the other hand, you have materialized views, which store their results on disk. This means they provide much faster read performance, especially for complex stuff, because all the hard work has already been done.
And there you have it. We've gone from the high-level filing cabinet of a database all the way down to the individual files, our BSON documents. And we even learned how to create custom windows into that data using views. So the only real question left is, what amazing application are you going to build with this?